All right, we're going to finish up our parametric model here. So what we built in class was this chunk here. We have our starter definition over here. We have the first three clusters that we built, the footprint, the extrusion height, and the extrude building. We've copied them down like so. And now we're going to go over this last chunk here. So let's go through a few things. I'm going to grab everything and hide it. So I've cleaned up the inputs so that'll be a little bit easier to follow. So remember, you want first, we're going to create our new footprint like so, which is set back from our original footprint like so. So we can see that, right? And that's controlled by this first setback distance. So we can control that. And everything is clearly labeled. So our inputs to the footprint, we have the vector that points towards the rear, which I've misspelled. We have the first setback distance, and we have the street edge, as well as the original footprint curve, right? So those are all the inputs that come in here. And that original footprint curve, just in case you lost track of it, is from back here. It's just that rectangle that we made. Okay, our next little cluster here is what gives us the extrusion height, right? So this is the height up to the sky exposure plane. And the inputs for that are the footprint, the curve, the sky exposure plane itself, and the street edge. And so again, we are finding our little curve here, and we're going to project that point upwards until it hits the sky exposure plane to give us this height. So the output here should just be a single height. And lastly, we are going to extrude our building. And so the inputs there, we need the height that we're going to extrude it to. We need the floor-to-floor height. We need the amount of area that is remaining that we have not built yet. And in the case of this first guy here, and we're just building this sort of first block, like the podium of our tower. The area remaining for that first block is all the area we have in the model. So it's our ZFA. And of course, we need our footprint that we're going to extrude. So the outputs from that should be our massing. We should have a footprint here that is on top of our massing. That's going to be the new footprint for the next block of the building. And we should have an integer value for the area that is remaining. Now, at the end of the workshop, we somewhat hastily took these three guys and copied and pasted them down. And the inputs into those, there were a lot of questions about that. We were moving pretty quick, and things got a little confusing. So let's go through it. We are going to first create a new footprint, which is the same logic as before, right? We are taking the sort of original footprint, which in this case is the sort of adjusted footprint from the ground floor. We've moved that up, and we're setting it back again. But here we want to have the value for our second setback, right? So again, if I highlight this so it's green so you can see it, we have two values here and they're different, right? And we want to be able to control this setback distance and have it be separate from this. So you need to make sure for this footprint that you have a separate setback to value, and also that your footprint that you're adjusting is from here, is this guy that's on top of the podium. Otherwise, if at the end of this, if you plug in the footprint from below, you'll end up, instead of having a second box here that's on top of the first box, you'll have another box on the ground that's sort of intersecting with your podium, and you do not want that. So it's always a good idea when you have clusters to sort of visualize, to like have the components on the outside of the cluster. We were moving pretty quick, so we had a lot of like hidden wires coming into these guys. It's good to have everything here so that you can double check that your inputs are rational, that they're what you expect. So again, your vector pointing towards the rear, which I've also misspelled, the setback, the second setback value. The street edge is the same street edge at the front here. You can see it here. Because again, we're just using that to determine like distances and sort our edges. And you want the footprint from here, from the top of the podium. Next, we'll figure out the extrusion height to the sky exposure plane. And those inputs are your new footprint, which is right here. Your same street edge, same sky exposure. And that will give you an extrusion height, like so. And then we're going to extrude the building. And so for here, you need to make sure that you have your new extrusion height. You do not want to have the extrusion height from the first cluster. So you have your new extrusion height. You have the same floor-to-floor value. The area that's remaining should be coming out here, right? Which makes sense, right? We calculated after building the podium, there's a certain amount of area remaining. It's no longer the ZFA because we've used up area in this first box. So this is what's left over after the podium, and we use that to determine, once we've built this second guy here, how much area is remaining after that. And if we had a really low FAR, this might be 0, right? We built a check into this script, remember, to take the minimum number of floors that were either calculated based on the available area or calculated on the sort of maximum extrusion height. So this second podium is just, or it's not podium, but this second block of the building is exactly the same in terms of code as the first block. You just want to change the inputs, which is why we clustered them, why we made them sort of repeatable. Now we're going to build the tower. Whoops. Back up for a moment. Don't worry, I'll explain how to build all this. So now we're going to build this third part of the building, which is our tower, which again, the concept here is that we are in a high density district. And so as long as our tower footprint is less than or equal to 40% of our entire parcel, we can break through the sky exposure plane and make it as tall as we want. So the first thing we're going to do is calculate that new footprint. I'm going to go back and turn this off. So we're going to use the exact same footprint cluster that we used before, and this will calculate our tower footprint. The inputs that we need for it, as before, we have our vector, which always points towards the rear of the building and is always misspelled. We have a setback value, but this is going to be sort of procedurally generated, meaning we're going to write a little bit of code to automatically calculate that distance based on the input parcel and the two setbacks that we've already chosen. So we're going to calculate this. The other inputs are the same old street edge and the footprint that we're going to modify, which in this case is the footprint coming out of our second block of the building, right? So how do we determine what this setback value is? Well, what we're going to do is figure out what the total required setback is to reduce this parcel to 40% lot coverage. And then we're just going to subtract the sort of ground floor plaza setback and this upper level setback. And that'll tell us what's left over as a final setback. So to do that, we're going to build up this little block of code right here. So to start, let's turn off everything again. If you click this button here, you won't see anything in Grasshopper except what you've selected. So we're going to select this original footprint. And as before, you're going to explode curve, like so. When you explode it, that will give you your 4 segments. You'll find the point on curve. So again, this is just explode, gives us this guy. and then point on curve gives us this little guy, which is always set to the midpoint by default. Use pull point to pull all of those points, all of those midpoints here, which are the midpoints of our segment edges, right? Pull those points to the street edge, and that will give you the distance that they've traveled to get to that street edge. You can then sort the segments by those distances. So the distances goes into keys here, and the segments from the exploded footprint go into the values. And so now they're going to be ranked by that distance. So this might be a little bit easier. Turn all that off. So we have these 4 segments, and here they're ranked. What we want, previously we were pulling the 0 item, which is always the closest item to the street edge. But what we want to do here is pull the first item, which will be this long edge here. Oh, actually, it's, for whatever reason, both of this edge and this edge are the same distance. Their midpoint is the same distance to the street edge. So it's sort of arbitrary which one Grasshopper grabs. But the point is, the next item in the list, sorted by distance to the street edge, will be either one of these long edges. And we want to know the length of that edge so that we can figure out how far to set back the edge to get to our 40% lot coverage. So if we take that distance, if we take 60% of that distance as our setback value, then we'll know that if we had done no prior setbacks, if our prior setbacks were 0 and 0, we would need to set back 60% of this edge to get back here to 40% lot coverage. So that's what this gives us. This is just multiply. So we multiply the length of our long edge by 0.6. That gives us 60% of its length. And we subtract from it the distance of setback 1 plus, this is addition here, plus setback 2. So we subtract that here from that value, and that gives us our setback distance. And so when we plug that in as the setback value, our new footprint, and again, this is up here because it's built on top of the first 2 parts of the building, but that distance will always be the same regardless of how much we change these other setbacks, right? So it's going to move up and down, which is a little confusing because of the fact that it's built on top of our other 2 buildings. But the dimensions of it will always be the same, and it will always be on top of the other 2 parts of the building. So we can turn those on if we want to visualize it, like so. So it's always going to be that size, and it's always going to be on top of our other 2 parts of the building. Okay, so I'll pause here for a moment just so that you can look at the screen. But again, explode, take the midpoints, pull them to the street edge as we did before to find the distance, sort, pull out the long edge. So again, Grasshopper is counting from 0. So the first index is actually the second item, right? This is going to be our 0th index. One of these long edges will be the first index. Find the length, multiply by 0.6, add together the first 2 setbacks, add them together, and then subtract that amount from the first setback. Okay, so now we have our footprint. So here, this is a little bit simpler than with our first 2 steps here, right? Because all we're going to do, the distance here in the z value that we're going to extrude that curve to, doesn't care about the sky exposure plane. It only cares about how much area we have left. So we take our area remaining, which is our output right here from this guy, from the end of our second step, right? We take that area remaining and we divide it, this is division, by the area of our curve footprint, right? So that area divided, that total area that we want to capture, divided by the area of the footprint, is going to give us the number of floors, right? So in this case, 23. The number of floors times the floor-to-floor height will give us the extrusion height, in this case 322 feet. If we extrude that box in the z direction, and again, you can just type z to get a unit z vector, and when you take this height, 322 feet, or 322 of whatever units your Rhino model is in, if you open up a panel, this is going to give you a vector that is, its length is equal to the input here, this distance, 322, but it's now a vector that has a 0 dimension in the x direction, 0 in the y, and 322 in the z. And so we can now extrude that model straight up, like so, and then we cap it to make a closed polysurface. And then for visualization, all I've done here, let's just turn everything off. Control A to select everything and then disable the preview. So here I'm taking a merge component and I'm just adding in, I've got my tower, and then I've got my massings from earlier, right? So this one is right here, the first guy, and this guy is our second guy, like so. I've merged them together. This component, solid union. And again, remember, there's two components here. So solid union is what you want. If you type set union, you will also get a component that is S union, but that's not what you want. That's a mathematical operation for joining sets together. So it'll have two inputs. You do not want that guy. You want solid union. That is going to, if we look at our inputs here, we can see how there is a thick wire coming in because there are 3 B-reps. Coming out, it's going to Boolean them together into a single closed B-rep. And then just for visualization's sake, we are going to merge faces. And that will just take, right now we have these edges in the middle of our faces. And if you use merge faces here, like that, that is going to merge those faces into a nice clean surface like that without those edges. Lastly, we're just going to do a little bit of visualization to make it a little bit prettier. So instead of this sort of red transparent grasshopper preview, we're going to use the preview component. This is custom preview. So you can just custom preview here. And what custom preview wants is some geometry to preview and a color swatch. So just type swatch. Boom, like that. And I'm just going to use white, which is nice for shading, but you can't really see the edges. So this guy, deconstruct B-rep. Just type D-rep right here, deconstruct B-rep. And that will give you the faces, the edges, and the vertices of your B-rep that you're deconstructing. If you take the edges and you put them into a preview, you can take a black swatch. That'll give you a nice little outline like that. And so there you go. So now I have that final B-rep that we're creating. And if we go all the way up here, we can turn on our sky exposure plane so that we can see that. And if we go to our inputs, we can now change the vertical distance of that sky exposure plane. And we can see how the building reacts. We can also change the base height. As we drag that down, you can see how we're getting more or less area in our podium, right? That's affecting how much area is left over in the tower. And we can go here, we can change the amount of built area. We can change the plaza setback. If we reduce that to 0, we come and sort of have to squeeze in under the sky exposure plane, or we can increase it. We can increase that second setback like so. And you'll notice again how the width of the tower doesn't change, because it's always going to be at 40% of the lot coverage. So I think that's about it. We got pretty far in the workshop getting through these two. And again, if you're having trouble, talk to your classmates. At least one of you should have this working. But I can almost guarantee you the challenges are in the inputs, and just making sure that as you copy and paste these guys down here, that you have the right inputs. So you have your second setback coming into your footprint. You have the new footprint curve, so on and so forth, everything that we've already gone through. Okay, that's it. We'll see you at the next workshop.